CySCPro or CRISPro. CRISPro is blockchain-enabled cyber supply chain provenance framework for energy delivery system. So we shorten the name as CRISPro. So these are the authors of this work: Eranga Bandara. I am the presenting author. Deepak Tosh, Sachin Shetty, Vesha Krishnappa. First of all, I will give a bit introduction about me and some background of the researchers that we have been involved. I am Eranga Bandar, currently working as a senior research scientist at VMAS, Virginia, US. So I involved with various research on blockchain, distributed systems, cybersecurity, machine learning, federated learning kind of areas. Actually, there's one main motivations of our researchers. We always trying to do research and take this research into production level applications. So that's our main motivation. So CRISPro is one such platform that we have built, production ready application that we have built based on one of our research work. So I'm available on Twitter. This is my Twitter username. If want, we can contact via Twitter as well. Let's look at some background information. Enterprise level energy delivery systems, we call it EDS, rely on number of software or hardware providers. Basically, there will be various software hardware vendors who provide systems for EDS. Most of the time, overseas suppliers manufacture and integrate critical EDS components. So the most of the critical components of the EDS provided by the overseas suppliers. It increases the attack surface for parties who are looking to enter the EDS. For example, so since most of the time overseas suppliers providing the critical component, there will be an attack surface to easily enter to the software hardware products provided by these suppliers for the EDS. For example, most recent event happened is SolarWinds supply chain attack. Some attacker joined for the company who produced the SolarWinds software and inject malicious software component to steal the data. So that's one such example which happened with the supply chain attacks in the EDS systems. So due to this reason, so EDS supply chain requires cyber risk management that can track cyber vulnerabilities. Further, it need to be facilitate a remediation plan to effectively mitigate the such risks. So these are the major requirements of the supply chain on EDS. So with this research, we propose a cyber supply chain provenance platform, so-called CRISPR, for EDS by using distributed ledger technology. It enables cyber risk management capable to defend and respond to the cyber supply chain attacks. Example would be that SolarWinds, that kind of attacks can be mitigated. Further, establish data provenance in a cyber supply chain ecosystem. Our contributions towards the CRISPR platform. We propose blockchain-based cyber supply chain provenance platform for EDS. The permission blockchain has been used to record all the physical and software assets in the EDS, as well as the supply chain provenance data. Further, we used to store the audit logs on the blockchain-based audit storage as well. The audit logs of the software, hardware assets, and entities are stored in the CRISPR platform using the blockchain-based audit storage. Finally, we support NERC CIP compliance requirements. NERC CIP stands for North American Electric Reliability Corporation's Critical Infrastructure Protection. So NERC CIP compliance defines some standards that need to be followed in the supply chain of the EDS. For example, is define various criteria that need to be satisfied from the software hardware vendors to the companies. So example would be, so there could be some vulnerabilities identified in the software hardware products. In that case, those vulnerabilities need to be notified to the companies who using that product. So then there's other criteria. If there's a new updates available with the system, these kind of updates need to be notified to the companies who using products. So there are, I think, several criteria that need to be satisfied via the NERC compliance. We support this NERC compliance on top of the blockchain platform. We encoded all the NERC compliance requirement into blockchain smart contracts. Then CRISPR overview. So this is the high level overview of the system. So there could be three type of stakeholders in the system: so vendors, energy companies, and crypto service provider. Vendors are the entities who provide software hardware assets. So companies purchase these software hardware assets, assets or products from the vendors. So then service provider is the governing body of this platform. Main thing to notice here is, so each and every entity could deploy a separate blockchain node on this system and collaborate in the system. So multiple vendors and companies can collaborate in the blockchain environment. So blockchain node can deploy in each and every vendor and company. The smart contract handles supply chain provenance functionality. Further, smart contract facilitate NERC compliance agreement between vendors and the companies. CRISPR provides web and mobile client application for end users, basically companies and vendors to interact with the system. Then let's look at the architecture of the CRISPR. So we designed this system as a layered system. So there are four main layers: blockchain layer, smart contract layer, stakeholders layer, and off-chain storage. Blockchain ledger stores all the software hardware asset information, provenance information, audit log information, as well as identities of the stakeholders in the system. So that's the blockchain ledger. So then smart contracts. Smart contract facilitate all the blockchain ledger functionalities. So there are four main smart contract in the system: identity contract, asset contract, agreement contract, and notification contract. Identity contract responsible for handling the digital identities of the vendors and companies in the system. We have used self-sovereign identity-based approach to manage the identities. We encode all the identities of the vendors and companies in as a DID or decentralized identity and stored on the ledger. So there is identity handling functionalities implemented on the identity contract. Then asset contract, all the software hardware assets life cycle and management handled with the asset contract. The agreement contract facilitates the NERC agreement contract. So all the NERC compliance requirement we embedded into the smart contract. Notification contract. So based on the NERC compliance, there are various notifications that need to be raised between companies and vendors. So all these notifications handled with the notification contract in a peer-to-peer real-time manner. So then stakeholders. So as mentioned previously, there are three types of stakeholders: vendors, service provider, and company. They reside on the stakeholder layer. So the main thing is, so there will be separate blockchain deployed for each and every stakeholder. Finally, the off-chain storage. So each blockchain node in the system linked with the off-chain storage to guarantee the privacy of the data. So we facilitate a way to store the uh, private data of stake of the stakeholders in the off-chain storage. So we guarantee some privacy requirement with that. Yeah, so this is the thing: distributed ledger, smart contracts, stakeholders, and off-chain storage. Okay, so CRISPR functionality. So let's look at the functionality of the CRISPR. So there are four main functions: identity registration, asset lifecycle management, NERC compliance agreement, and notifications. So this is the high-level flow of the functionality of the system. So as I mentioned previously, three stakeholders: vendors, service providers, and companies. First, service provider. So basically, CRISPR service provider handle the registration of vendors and the companies into the platform. So they initially register all the vendors and companies in the system. So once registered, so vendors and companies can onboard it to the platform via using the web application. Vendors basically provide software hardware assets. So then vendor need to register their software hardware products in the ledger, so via the web application. So then companies can purchase these products from vendors. When purchasing the product, so there will be agreement formed between vendor and company with relate to the NERC-CIP compliance requirement. The agreement term define what are the criteria that need to be supported by the vendor. Yeah. So then, in order to be a approved software asset, so that agreement need to be accepted by the vendor. So that's the thing. Once agreement is accepted, officially that asset will be onboarded to the company. Okay, so then, as I mentioned previously, there are various notifications that need to be raised between vendors and companies based on the NERC-CIP compliance requirement. Assuming, and in some scenario, vendor identify a bug or issue on the products, in that case, based on the agreement, so they need to notify that incident to the companies who use in that product. So this notification will be raised from the vendor to the company via the CySCPro platform. So that's the high level functionality. This is the that application that we have provided. We provide some web application. So this is the vendor profile. So vendor can list all the software hardware product information. So then once goes to the specific product, so they can use view who are the companies using that product. So then that companies can onboard assets, basically when purchasing product from a company vendor, it identified as assets, so they can onboard assets. So the important thing is NERC-CIP compliance requirements when onboarding assets. So there will be an agreement will be formed. So company need to choose what are the agreement requirements that need to be support from the corresponding software hardware vendor. For example, notification by the vendors identifies cybersecurity risk, remote on-site access related agreements, so known vulnerability related agreements, verifications of the software, and authenticity related agreements. So company choose what are the agreements that need to be satisfied by the corresponding vendor. So once this agreement accepted, so product will be officially onboarded to the company's profile. So then notifications can be generated. It also facilitated so for the products. So this is the way we handle the notifications. Yeah, finally, CySCPro implementation. We have done a production ready version of the CySCPro platform. In here, so this is the architecture of that production implementation. So there will be a blockchain network deployed between vendors and companies and the service provider. Each blockchain node comes with smart contract service and off-chain storage. Peer-to-peer communications we are supporting. So by using Apache Kafka based message broker. So basically the platform built with microservices architecture. Services are deployed with Docker, Kubernetes, and Helm charts-based orchestration system. Microservices communication implemented with Kafka using reactive stream-based approach. So the blockchain functionalities we implemented using Rahasa blockchain. Rahasa is another research work that we have done in the enterprise level blockchain field. So Rahasa is a highly scalable blockchain storage for enterprise level applications. So it can support big data, IoT, banking, finance kind of enterprise level application requirements, high transaction throughput, scalability, sharding kind of features. In here, the Rahasa blockchains comes with functional programming and concurrence enable smart contract platform, which built on top of actor-based concurrence handling. All the blockchain functions, smart contract functions implemented on top of Apple's smart contracts. Firebase used to the peer-to-peer communication because that there will be various notifications forms between companies and vendors. we have used Firebase push notification to handle this notification. Then we have used Apache Cassandra based off-chain storage. So each blockchain peer have their own off-chain storage to store the privacy preserving data. So we have used Apache Cassandra as the off-chain storage. So the authentication and authorization of the platform handled with JWT, JSON Web Token based auth service. Yeah. So that's the high level architecture details of the RESPO implementation. Uh, yeah, that's it from my side. If we have any questions, we can discuss them now. Okay, thank you very much for your valuable time.